Welcome to an optimization problem from economics. So R of X is the revenue from selling X items, C of X is the cost of producing X items, and P of X is the profit from selling X items. And you find your profit by taking the revenue and subtracting the cost. If we take the derivative of revenue, that's called marginal revenue. If we take the derivative of cost, that's called marginal cost. We take the derivative of profit, that's called marginal profit. And marginal profit, your greatest profit occurs when the marginal revenue equals the marginal cost. So if we set marginal revenue minus marginal cost equal to 0 and solve, and if we add marginal cost to both sides, we get marginal revenue equals marginal cost. So suppose R of X equals 9x, and suppose C of X equals 3x squared minus 12x plus 15. To find the production level that maximizes the profits, we would set these equations equal to one another. In other words, the marginal cost, set that equal to the marginal revenue. All right, so to find the marginal cost and the marginal revenue, all we have to do is take the derivative. All right, so that's pretty easy. All right, so R prime of X would be 9, right? The derivative of 9x is 9. It's just a linear function. Of course its slope is 9. And the derivative of the cost function, the power rule, so 3 times 2 or 6x, and then minus 12 would be the derivative. Of course, the derivative of a constant is 0. So now we want to just set that equal to one another. Right? So 9 equals 6x minus 12. So let's add 12 to both sides. So 21 equals 6x. And if we divide by 6, x would equal 21/6, or we could reduce that. They're both divisible by 3. So that would be 7/2 or 3.5. All right, so that's the production level that would maximize the profit when x is equal to 3.5 whatevers. All right, so here's a nice simple example from economics. Let's do another one that's got a little more context to it. It's also actually a pretty simple problem, but at least it's got some context. I don't even know what we're selling here. Rags Limited, a clothing firm, determines that in order to sell X suits, the price per suit must be P equals 150 minus 0.5x. It also determines that the total cost of producing X suits is given by C of X equals 4,000 plus 0.25x squared. So first we want to find the total revenue. Right? That's just going to be an equation. And total revenue, R of X, would just equal the number of suits sold, which is X, we're selling X suits, times the price of each suit. Actually, I'll put X suits. Times the price per suit. Right, so that means X, that's going to be the number of suits, times the price per suit is 150 minus 0.5x. So if we distribute the x, we have 150x minus 0.5x squared. And actually, I'm going to make that 1/2. I'd rather deal with the 1/2. It's easier for me when I have to multiply and stuff. All right, so 150x minus 1/2 x squared. That would be the total revenue. The total profit, we would just take, so profit, I'm going to switch colors. Let me move those equal signs. Can I move that up just a little bit? I think you can read that okay. All right, so profit is just revenue minus cost. Right? So that means P of X would be 150x minus 1/2 x squared. And then we'd subtract the cost function, which is given to us above. There we go. That 1/2 is just disappearing. And so that was 4,000 plus 0.25x squared. And now let's combine the like terms. I'm going to finish C or B over here. Right, so that would be P of X equals, I'll probably do all the others down here. 150x, unless I've got enough space, 1/2 x squared minus 4,000, and then minus 0.25 x squared. Let's just make that 1/4. So we can combine like terms. Got a few of them. Well, two of them. P of x equals 150x, and then that would be minus 3/4 x squared, and then minus 4,000. All right, so that's the profit equation. How many suits must the company produce and sell in order to maximize the profit? All right, so now if you remember from the other page, how do we find when we maximize the profit? All right, it's when the marginal cost equals the marginal revenue, right? And marginal cost minus marginal revenue is just marginal profit. So we've already combined the terms, so we could take the derivative of the revenue and then take the derivative of the cost and then set those equal to one another. But since we've already combined r of x and c of minus c of x, we could just take the derivative of the profit. It's the exact same thing. All right, so let's do c, and I'm going to do c in red over here. All right, I've already combined the like terms, so rather than having to combine the like terms second time, we'll just use the combined like terms. The derivative of 150x is 150. The derivative of negative 3/4 x squared would be 3 times 2 would be negative 6/2, which is 3/2 x. And then the derivative of the constant is 0. All right? So now we set that equal to 0. It's the exact same thing as finding the derivative of the revenue, derivative of cost, and setting it equal to one another. Right? We just combined the revenue and cost first because it asked us for the profit function. So we have 0 equals 150 minus 3/2 x. Right, let's move the 3/2 x. So 3/2 x equals 150. Of course, if we divide both sides by 2/3, we'll get x. So x equals, so 150 divided by 3 is 50, times 2 is 100. So x equals 100 suits. That's how many suits the company must produce and sell in order to maximize profit. Right? So x equals 100 suits. What is the maximum profit? We'll just plug that back into the profit equation. All right, so P of 100 equals, it's right down here at B, 150 times 100 minus 3/4 times 100 squared minus 4,000. And I'm just going to use a calculator, and I'll tell you how much that is. Oh, it's really getting dark in here. I'll have to stand by the light of the board. So 150 times 100, and then minus 0.75 times, whoops, got a times in there, times 100 squared minus 4,000, so 3,500. They're not making a whole lot of money, I guess. Of course, we don't know profit for how long, I don't know. So this is 3,500, maybe it's per day, that wouldn't be so bad. That's $3,500 is the maximum profit. What price per suit must be what price per suit must be charged to make this maximum? Now we just use the price equation. And so the only calculus part was taking the derivative and setting it equal to 0. After that, it was all just, once we knew what the number of suits that they should make is, we're just all plugging it. Hey, why didn't that underline? We're just plugging that into the equation. Any day now. Whoops. There it goes, like 3 times. All right, so price 150 minus, and then that's 100 divided by 2. That's going to be a $100 suit. So $100 per suit. These are obviously high quality suits if you can get them for $100. That's why it's called Rags Limited, I guess. Well, it looks like we've answered all the questions, and so this was a nice little application problem and a nice way to end optimization. Thanks for watching. Bye for now.